All right, anybody that knows me knows I'm all about theory. Because without the theory, you really don't have a chance when it comes to diagnostics like we have in 2.1 or even in some of the more complicated design questions that may actually be posed inside of CCIE Data Center version 3 coming up in February. So what we want to do is we want to make certain that we talk about this when and where possible. So what we have in our infrastructure is we have spine 201, and we have spine 202. And what I want to do is I actually want to configure these resources in such a way that they are going to provide my rendezvous point services. So satisfying the requirements of the rendezvous point. Now all I have to do is go into my system and I could use Anycast RP, Bootstrap Router, Static Assignment, and I could pick one of these guys to be in charge of my rendezvous point environment. But what I want to do is I actually want to configure something called an Anycast RP, and we're going to make reference to these resources acting in this Anycast RP environment by creating an Anycast RP set. Now, what I need to do in order to be able to make this work is I need some interfaces. So what we're going to do is we're going to create two sets of interfaces. The first interface is going to exist on each of these devices, and it's going to use a unique addressing schema. Then what I'm going to do is I'm actually going to create an IP address and an interface, and what will end up happening is these are going to actually share the same IP. So these will share IP. These will be unique. Now what we'll end up doing is these unique variables are actually going to represent each of these individual devices inside of my Anycast RP set. So the object is that however many devices that I have participating in the rendezvous point set, they need to know about all of the other devices, because ultimately these resources are going to intercommunicate amongst themselves. And we're going to actually look at that when we get a working VXLAN environment using this flood and learn mechanism that we've been discussing. So the object is we need to have addresses that are going to be unique, and we also need to have addresses that are going to be shared. So what I'm going to do is I'm going to create a shared address. So the shared address will be 10.1.200.200. So that's going to be my shared address. I'm going to create two unique addresses, one for Leaf 101, and I'll just move my laptop out of my way here. So one for Leaf 101, and it's actually going to be 10.1.200.201. Sorry, I said Leaf 101, it's Spine 201. And then what we'll do is we'll create one for Spine 202. It will be 10.1.200.202. So here are my two unique addresses. Here is going to be my shared. Now the way that I'm going to do this is I'm going to create interfaces on these devices. So I will create loopback 201 and loopback 202. And then what I'll do, this shared interface is going to be loopback 200. LO 200. Now, interestingly enough, for this to function, these interfaces have to be advertised in OSPF because they have to be reachable, and it's also going to need to be noted that they must be PIM enabled. Now the benefit here is that when we start looking at the implementation, these two devices can both service as rendezvous points. So this device would be able to function as a rendezvous point, this device will be able to function as a rendezvous point, and we should be able to create the missing element in our VXLAN config. So ultimately what I want to do is I want to take this, make it real in the next video, and then what we're going to do is we're going to take the last steps with regard to creating those logical NVE interfaces that we described, and I can't wait to get started, so I'll see you guys there.